NASA's amazing telescope is set to redefine the entire whimsy stare at the stars. In preparation for Webb's very first cosmic discoveries, NASA is racking up a list of exciting interstellar targets. It has announced that their telescope has uncovered a pair of scorching super-Earths that pretty much sound like Star Trek worlds. And the most flabbergasting thing? One is covered in lava oceans and the other exists without an atmosphere. James Webb Space Telescope has set its eyes on a couple of super-Earths who are so close to their stars that a year on them is less than 24 hours. These are actually two hot exoplanets that are classified as super-Earth due to their size and rocky composition. The term only concerns the mass of the planet and does not imply anything about the surface conditions or habitability. Now, what would happen if the Earth was much closer to the Sun? So close that a year on the planet would be just 18 hours long. Certainly, humanity as we know would not exist. Then what would evolution look like? It seems like the James Webb Space Telescope is on its way to find out. The general science operations of the James Webb Space Telescope, or the work it's designed to do, includes observing the infrared universe, analyzing the data collected and publishing scientific papers on their discoveries. Beyond what is planned, there are unexpected discoveries that scientists cannot anticipate. For example, in 1990, when the Hubble Space Telescope launched, dark energy was a complete unknown. Now it is one of the most exciting areas of astrophysics. What will Webb uncover? Beyond imagination as of now. So, for the first year of investigations, Webb will study the two super-Earths, the lava-covered 55 Cancri E and the airless LHS 3844b. Researchers will train Webb's high-precision spectrographs on these planets to understand the geologic diversity of planets across the galaxy and the evolution of rocky planets like Earth. One might wonder, why is this discovery a big deal? Let's see for ourselves. So, 55 Cancri E orbits less than 1.5 million miles from its Sun-like star, which is like 1/5 of the distance between Mercury and the Sun, completing a circuit in less than 18 hours. With its surface temperatures much above the melting point of typical rock-forming minerals, the day side of the planet is thought to be covered in oceans of lava. Planets that rotate this close to their star are assumed to be tidally locked, which means one side facing the star at all times. If the planet is not locked, it would experience day-night cycles. Scientifically as well as intuitively speaking, the hottest spot on the planet should be the one that faces the star most directly, and the amount of heat coming from the day side should not change over time. Unexpectedly, this does not seem to be the case here. Observations of 55 Cancri E suggest that the hottest region is offset from the part that faces the star most directly, and the amount of heat detected from the day side does vary. Interestingly, the scientists could name few possibilities for this. One could be that the planet has a dynamic atmosphere which moves heat around. Another intriguing possibility is that the planet is not tidally locked. Instead, it may be like Mercury, the closest to our Sun, rotating 3 times for every 2 orbits. Then the planet would have a day-night cycle. In this scenario, the surface would heat up, melt, and even vaporize during the day to form a very thin atmosphere that the Webb could detect. In the evening, the vapor would cool and condense to form droplets of lava that would rain back onto the surface, turning solid again as night falls. While 55 Cancri E will provide insight into the exotic geology of a world covered in lava, LHS 3844b affords a unique opportunity to analyze the solid rock on an exoplanet's surface. Like 55 Cancri E, LHS 3844b orbits extremely close to its star, completing one revolution in 11 hours. However, because its star is relatively small and cool, the planet is not hot enough for the surface to be molten. Additionally, Spitzer's observations indicate that the planet is very unlikely to have a substantial atmosphere. While it might be possible to image the surface directly with Webb, The lack of an obscuring atmosphere makes it possible to study the surface with spectroscopy. The team will use MIRI to capture the thermal emission spectrum of the day side of LHS 3844b and then compare it to spectra of known rocks like basalt and granite to determine its composition. If the planet is volcanically active, the spectrum could also reveal the presence of trace amounts of volcanic gases. There are about 5,000 confirmed exoplanets in the galaxy. The importance of these observations goes beyond just two of them. It can give a new perspective on Earth-like planets in general and an idea about what the early Earth might have been like when it was hot, like these super-Earths. The James Webb Space Telescope is the world's premier space science observatory. While some of the largest ground-based telescopes on Earth use segmented primary mirrors, Webb is the first telescope in space to use such a design. Webb will solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe the mysterious structures and origins of our universe and our place in it. Launching Webb to space was of course an exciting event, but for scientists and optical engineers, this is a pinnacle moment when light from a star is successfully making its way through the system down onto a detector, said Michael McElwain, Webb Observatory project scientist, NASA's Goddard Space Flight Center. NASA designed the James Webb Telescope as a follow-up to the hugely successful Hubble Space Telescope. It has been in space for 6 months, which is only a fraction compared to the time spent in building and designing the telescope, and the efforts are already paying off. It has been a success so far, from going through steps like traveling 1 million miles from Earth to aligning its 18 hexagonal gold-plated mirrors. The James Webb Space Telescope is now just weeks away from full operation. Now, as far as the super-Earths are concerned, how the James Webb Space Telescope comes into play sounds quite interesting an event. It's like the two exoplanets are the two muses of the Webb. Now, an interaction between them will be quite a sight. Consider our ExoMuse 1, the 55 Cancri E. The muse's proximity to its sun leads to a major mystery. On one hand, Hu and fellow researchers are determined to get to the bottom of this by training Webb's groundbreaking near-infrared camera and mid-infrared instrument on the day side of the planet. These technologies come with the power of infrared imaging to see what the human eye can't. The light emanating from the infrared region of the electromagnetic spectrum, but these instruments can pick up on those photons, even when they originate in deep space, and translate them to signals readable by us. If it has an atmosphere, Webb has the sensitivity and wavelength range to detect it and determine what it is made of. And on the other hand, Brandecker and fellow researchers also plan on using NIRCam to measure the heat emitted from the lit side of 55 Cancri E during 4 different orbits. A bit farther from us than 55 Cancri E, exactly 48 light-years, lies this very hot, technically cooler, extrasolar planet called LHS 3844b. So the riddle is the lack of substantial atmosphere here. Webb can decode it using its powerful infrared spectroscopy mechanisms. While it's awesome to have found these 2 exoplanets, this merely scratches the future potential of the telescope in coming years. Researchers worldwide have already started adding to this list, like one crew identifying extraterrestrial biosignatures and another team concentrating on a supermassive black hole ancestor. This could also solve the puzzle of why Neptune is getting colder and give us a beautiful view of Earendel, the farthest star ever seen by humans. Interestingly, the story is not ending yet, and, well, something about using the word end while talking about the universe still smells controversial. But we've got something as controversial here. Remember the genius Stephen Hawking and one of his most controversial theories suggesting that dark matter may be made of black holes formed in the earliest moments of the Big Bang. So, black holes are formed only after massive stars die, then collapse under the weight of their gravity. Making black holes requires many stars, which requires a bunch of normal matter. But there simply isn't enough normal matter to make all the dark matter. Stephen Hawking suggested that the black holes formed in the chaotic environment of the earliest moments of the Big Bang, that these primordial black holes might be responsible for dark matter. The James Webb Telescope is specially designed to answer questions about the origins of stars and galaxies, with astronomers working on the potential reveal of the story of the first stars and potentially the origins of dark matter. James Webb has its hands full of puzzles, a key to a better understanding of the Earth and mysteriously more.